Do you have the questions? States of matter questions? Hmm?
No, no.
You didn't do them? So you didn't do your lab report, you didn't do your physics homework, so what did you do?
I'm 61.
Alright, fine. KJ?
Yeah.
Have you got the questions there? Okay. Materials, states of matter. Let's have a look here at the questions. Right. The first question was. Oh yeah. How do you think the speed of molecules change as a block of ice becomes liquid water? So what do you think? How do you think the speed of the molecules change?
Did you put the questions on the
I didn't. It was the weekend and I was busy actually. In fact, I was busy making physics notes last night. It doesn't matter, KJ.
Yep.
Questions are there now. So how do you think the speed of molecules change as the block of ice becomes liquid water?
Faster.
Yeah.
Faster.
Yeah. So for number 1 here, the speed of the molecules increase. Okay. So that's fine. Let's have a look at the next one. So, some cold water and some warm water, I should say, are placed in the freezer. Which will freeze first? So which will freeze first in the freezer?
Cold water.
The cold water or the warm water?
The cold water.
And why is that?
Because the molecules are slower.
So in fact, if you actually did this, the warm water will freeze first.
The warm water?
And in fact, this, now, if I can open up the internet here. Everybody thought, like you think right now, that if you put warm water and cold water in the freezer, the cold water will have to freeze first. It makes perfect sense. How could the warm water freeze faster than the cold water? Because before the warm water can freeze, it has to become cold water itself. Now, what's the name of this? There's now it doesn't always happen, but sometimes it does happen this way. Memba effect. So in fact, this one, I thought it was an interesting little story. This one here is named after Memba because he actually did this as a high school experiment.
Member?
Yeah. So he actually did this as a high school experiment. And I think now the principal, let's see. Where's his little story? Yeah, so he was, I think he's, which school was he in? Yeah, so when he actually asked the professor why, when he puts water at 35 and the other at 100 and puts them in the freezer, the one starts at 100 will freeze first. This is his question. And his classmates and teacher made fun of him. Then later I think the lecturer or the principal actually did do the same thing. He did at home in the freezer, he put boiling water in the freezer, and he put warm water in the freezer, and the boiling water freezed first. Which doesn't seem to make sense, right? So anyways, I'm just saying, even if it might seem obvious, until you actually do it, maybe it's not the way you think it is. The same reason why people thought heavier objects fall first, until somebody actually does it, you know. Right? So if this was a class 3,000 years ago, you would have thought a heavier object will fall faster. But you know it doesn't, right?
It does if there's air
If there's
resistance.
air resistance, yeah. But if you had two cannonballs, the heavier one, you would have thought landed first, until somebody climbs a tower and drops them. And then you see them land at the same time. So a bit like with the water here, you'd think the cold water will freeze first, but in fact, sometimes it's the warm water. So I'll just write here, sometimes the warmer water will freeze faster. Okay, let's have a look at the next question. Alright, so we're looking for materials that go from being a solid straight to being a gas.
There's one called dry ice,
Dry ice is one of them.
naphthalene,
Huh?
naphthalene.
Yeah, let's have a look actually. What's it called? Sublimation, isn't it? Let's see if we can find some examples. So I know there's a couple. The easiest one is dry ice. What is dry ice? Do you know dry ice?
Carbon
Carbon
dioxide.
dioxide.
Yeah, frozen CO2. Dry ice is one of them. Yeah. Ah, snow and ice. I guess if the pressure's right. Yeah, I suppose snow, snow doesn't really change into a liquid. I know a bit of it changes into a liquid, but if you think about snow on the ground, it goes from being snow to not being snow. You don't really see big puddles of water afterwards. Yeah, there's other substances here. Anyways, the most important one, or not the most important one, the easiest one is dry ice, which is just frozen CO2. So if you had this ice, and if you give it a bit of heat, it won't turn into liquid, it'll go straight into being a gas. It skips being a liquid. Yeah? Actually, maybe I got a picture of it. I can get you a picture. Let's have a look. Let's try and find some dry ice. Yeah, actually that's a pretty cool picture. So you can see here the ice, as it melts, it doesn't become a liquid, it goes straight into being a gas. Yeah, you see here, you can see the gas coming off of it. So it skips being a liquid. Alright, next, are there other states of matter? So last time, we said there are three states. Solid, liquid, and gas. But in fact, there is one other state. I wonder if anyone knows it.
Amorphous.
Huh?
Amorphous solid.
No, 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 no. Keep it simpler word than that. That's not what begins with P. No? No?
Plasma.
Plasma. Yeah, there's 4 states actually. Sorry, I shouldn't have closed the internet already. Plasma is the 4th state. That's what I was looking for. So, KJ, what do you know about plasma, if anything, apart from its name?
It's like the liquid in the blood.
Oh no, 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 no. That's biology plasma. We
Okay.
want physics plasma.
No, I don't know.
No, that's okay. I get a picture of it for you. Solid, liquid, gas, and plasma. It's one of the 4 states, and it's not like the others. Um, so usually you get it when something's really, really hot. I'm trying to find a picture of you.
What?
Um, nah, doesn't matter. I'll give you one example where you can get plasma in nature, which I know of, is when you have lots of lightning striking the ground. This can make some plasma. I think O3 is it? I'm not 100% sure. But anyways, when lightning strikes the ground, it can change the air from being a gas, because you know it's a gas now, into plasma. So I think I think this is how you make ozone. Do you know ozone?
Mm.
Yeah. So I think ozone is it was plasma, oxygen that went from being a gas to plasma, and then it floats up. I think this is where ozone comes from. Like
Why can't you make more?
you could, but I mean it's being made all the time, you know. So I mean the thing is, people do say about the hole in the ozone layer, things like this. But in fact, if you just stop damaging it, the hole will slowly close itself because there's ozone being made at ground level whenever there is a heavy lightning storm. Now when I say heavy, I mean like 20 bolts of lightning hitting the ground per second heavy. But in these parts of the world where you have heavy lightning storms, I believe this is where the ozone and plasma is made, which is what floats up and becomes the ozone layer. I think. I don't remember for certain, but I think it's that anyway. Okay, so the answer for the last one then is plasma. Okay, you got those 4 answers?
Yeah.
Yep. Okay, let's have a look at the next homework then.